In this video, we're going to review strategies for finding inverse trig values from the unit circle. Now, problems in this section will often look something like this: inverse sine of 1/2 or arc sine 1/2. To us, those are going to mean the same thing and they're interchangeable. Now, whenever we see a problem like that, we should, at least in our head, be thinking, oh, that's when we're asking, when does sine of theta equal 1/2? Now, if we wanted a picture of this, we'd be saying, okay, sine is the y value, so we'd be asking this question: for what angle theta do we have a y value of 1/2? So here's a 1/2, and boy, we've got 1, 2 answers, and we can keep going around and round, and so the next question is, which angle do you want? So we're going to take a look first at the domain on inverse sine and as well as inverse cosine and inverse tangent. Now, sine is a function, but when we look at the horizontal line test, we see that it doesn't pass that. And in order for the inverse to be a function, we need to restrict the domain on the original. So I'm going to just show you here, if we restrict the domain on sine from there to there, so from negative pi over 2 to pi over 2, we get this graph. And on our unit circle, it's this region where we have our domain on our inverse questions. For cosine, we can't do that same region because you can see if I went from here to here, it wouldn't pass the horizontal line test. So it actually goes from 0 to pi. And you'll see up here it goes from 0 up to pi. And so on cosine, we're looking for our answers between 0 and pi. Now in tangent, we're going to just take this section right here, and it's the same region as sine. It goes from negative pi over 2 to pi over 2, or from here to here. Now what I want you to remember is that it always includes the first quadrant, and it never includes the fourth quadrant. All right, so in sine, we're looking at the fourth and the first quadrant. Cosine, we do the first and the second. And in tangent, again, we do the first and fourth quadrant. All right, so let's put this into action. So here's our first few problems. And we're going to not have our unit circle right in front of us, because when we do these in a problem, we're going to need to be able to do them without a crutch. All right, so our first question, inverse sine of -1. The question in our head is, when does y equal -1? All right, so quick sketch of my unit circle. Y is -1 right there. It's only -1 one time. There's my answer, negative pi over 2. All right, let's try our next one. Again, it's sine. So when does y equal 1/2? That was the one we had started off with and we hadn't answered yet. All right, now if we have an answer in the first quadrant, that's the one we're going to take. Now you'll recall that sine, our answer had to be in 1 or 4. But when you see an answer in both 1 and 2, always take the answer in quadrant 1. And so it equals 1/2 when we're halfway up, and that's going to be at pi over 6. All right, now cosine is simply the x-coordinate. So for cosine, I'm going to say, well, when does x equal 1? So a little quick unit circle, x equals 1, well, it's only one place, right there, and that's at 0 radians. All right, now here we're going to ask, when does x equal -√2 over 2? I know that's going to be something over 4. Now -√2 over 2, I'm looking at an x right here, right? And remember I said the answer is never in this quadrant. So it's going to be this one right up here at 3 pi over 4. Okay. Now we're going to move on to inverse tangent, and the easiest way to do tangent or inverse tangent is to understand this relationship. So tangent is sine over cosine. So far so good? And sine, we just said, was our y, and cosine was our x, so that equals y over x. And we could all agree that y minus 0 over x minus 0 is the same thing as y over x. Well, what I'm really doing here is finding a slope. So here's my y, and it's going through 0, 0, and xy, and that gives me the slope of the line through the origin. So let me just show you what's happening here. So this is tangent, so I'm really only interested in these two quadrants, quadrants 1 and 4. And I'm going to just mark out using the letter M for slope. We'll take the easiest one right here. Here my slope is 1, and you'll see if I took y over x, right, root 2 over 2, and root 2 over 2, I get 1. All right. Down here it's, and we're not going to refer to this as 7 pi over 4, but this will be our negative pi over 4. Our slope is negative 1. All right, now I want you to notice here my slope is greater than 1, and here my slope is less than 1. And for exact values, those are the only ones I'm going to have. But this one is also bigger than 0, because here's my slope of 0. And right here, my slope is bigger than 0, but less than negative 1. And here, my slope is less than negative 1. And of course, along this vertical here, my slope is undefined. Okay. Now, when it comes to x values, when it comes to inverse exact values with tangent, we're only going to be working with values that fall at these places, pi over 2, pi over 3, pi over 4, pi over 6, and then of course down here, negative pi over 6, negative pi over 3, 4, and negative pi over 3. All right, so let's see how this works in action. So in this first one here, arctan of root 3, this isn't y or x, this is my slope. So I'm asking, when is the slope equal to root 3? And I should notice that root 3 is about 1.73, which means it's greater than 1. So if I look at my unit circle and I know my slope of 1 happens at pi over 4, then my slope greater than 1 is going to be steeper than that, which is going to take me to pi over 3. All right, let's try this next one. Now we're going to do, when is the slope equal to negative root 3, which is steeper. I'm going to use steeper than negative 1 because it's about negative 1.73. So if I take my graph again, I'm going to just reference here. That's my slope of negative 1, but I want it steeper. My steeper slope's going to be like this, and it's going to take me to negative pi over 3. And by the way, you're always going to have this situation with tangent where when you simply switch the sign, it's going to switch the sign here because it's an odd function. All right, and then let's look at this last one. We're asking, when is the slope equal to negative root 3 over 3? Now I want you to recognize that negative root 3 over 3 is less than 1, all right? Okay, so it's less steep than 1, but in this case it's negative. Okay, so what we have is, here's our negative 1, and we're going to be less steep than that, so that's going to be the one that comes in like this right here at negative pi over 6. All right, so now we're just going to mix them up and try a few different ones. So remember, ones like inverse sine 0, we want to know where is y equal to 0. All right, so we come in here. Our y value is equal to 0 in two places, right there and there. But remember, anytime we have anything over here, we choose this one, which is at 0. All right, the next one, we're asking, well, when is my x going to be negative root 3 over 2? Draw a quick unit circle, negative root 3 over 2x, that's going to be way over here. I get two values, but remember, I never want anything in this quadrant, and so I'm going to have, let's see, that'll be 5 pi over 6. All right, arctan negative 1. I'm asking myself, well, when does the slope equal negative 1? That's an easy one. I take this, draw it in, and it's going to be right over here at negative pi over 4. All right, let's try one more set. We have arc sine, negative root 3 over 2. We're asking ourselves when is y equal to negative root 3 over 2. So we've got our unit circle. We're coming way down here. And here's our y value. Remember, we never take anything in here. So it's got to be this one. And when we come down here, we come in the negative direction. So that's going to be negative pi over 3. All right, this next one, we're asking when is x equal to negative 1. Let's see, x equals negative 1 only one place, right there. And so that's at pi. And our last one, root 3 over 3, we're asking when does the slope equal root 3 over 3. Remember, root 3 is about 1.73 over 3. This thing's going to be less than 1, so less steep than 1. So if we draw our unit circle, remember 1 is at pi over 4, so if I'm less steep, I'm going to be this one right here, which is going to be at pi over 6. All right, I hope that helps out.